Alright, today I'm going to go over the Unit 8 series, Part 1 review. So our first question here is 8-2. What this is a combination. We can do it the long way, which would be 8 factorial over 8 minus 2 factorial, which would be 6 factorial times 2 factorial. Then you can rewrite this as 8 times 7 times 6 factorial over 6 factorial, and then 2 would be 2 times 1. So then we can cancel the 6 factorials. So we're just going to have 56 divided by 2, which is 28. Right, we can do something similar here. So I'm going to rewrite the bigger factorial in terms of the smaller one. So 12 times 11 times 10 times 9 factorial over 9 factorial times 2, which means we can cancel those out. And then you will have your calculator, so you type this in and get 660. This one we're going to do the same thing, it's just with variables. So I'm going to take the bigger one, which is going to be the top one, and write it in terms of the smaller one. So this one's going to be r minus 1 times r minus 2 times r minus 3 factorial over r minus 3 factorial. Okay, which leaves us with just r minus 1 times r minus 2, which you can leave it like that, or you can FOIL it, which would be r squared minus 3r plus 2. So this one we're going to do something similar. I'm going to take the bigger one and write it in terms of the smaller one. So we'll have n times n minus 1 times n minus 2 factorial over n minus 2 factorial. This is equal to 6. So I'll FOIL this out. So we've got n squared minus n equals 6. So n squared minus n minus 6 equals 0. N minus 3, n plus 2 equals 0. So algebraically, n equals 3 or n equals negative 2. However, we can't have a negative factorial, so that one is not a real solution, but n equals 3 is. All right, the next question. Lewis Palmer and Palmer Ridge are holding elections for their student council. At Palmer Ridge, the student council will be made up of a committee of 5 students from each grade. Each student will have the same amount of responsibility. So how many ways are there to choose the sophomore committee if 12 students are running in that grade? So this is going to be a combination because order does not matter. So we have 12 C5. Okay, and I'm going to remind you of how we can do this in the calculator. So in the calculator, we're going to hit the math button. Okay, that's going to open up all these different options. We want to go over to probability and down to NCR. So we have 12C9, which gives us 12C5. Let's try that again. 12C5, which is 792. Okay, at Lewis Palmer, each grade has 5 members. Each student selected will be given a title. Each grade will have a president, a vice president, a treasurer, a secretary, and a representative. If there are 10 students running from the junior, how many are there to pick the junior council? So this is going to be a permutation. So 10P5. Okay, and then in the calculator, we'll go math over to probability, down to a permutation. Okay, and this is going to be 10P5 which gets us 30,240. All right. My daughter puts her 10 crayons, all different colors, in a row. How many possible arrangements are there? So this again is going to be a permutation. It'll be 10p10. So just as a reminder for the formula, that's 10 factorial over 10 minus 10 factorial, which would be 0 factorial, which is just 1. So this would just be 10 factorial, or we can just do the same thing. That probability 10p10 is going to be 3,628,800 options. And trust me, she's probably tried all of them. All right, so we're going to write the first 5 terms of a sequence. So this one's going to be a recursive formula because it's in terms of the terms, not the term number. So here, A1 is just going to be 2. A2 is going to be 1 minus 3 times A1. So that's 1 minus 3 times 2, which is going to be negative 5. A3 is going to be 1 minus 3 times A2, which is going to be 1 minus 3 times negative 5. Okay, so that's going to be a positive 15, so this will be 16. A4 is going to be 1 minus 3 times A3, which will be 1 minus 3 times 16, which gives me negative 47. The last one then, A5, is going to be 1 minus 3 times A4, which is 1 minus 3 times negative 47, which will give us a positive 142. So if I write this out as a sequence, we have 2, negative 5, positive 16, negative 47, and 142. This next one is going to be explicit because it's in terms of n. So we'll plug in, if I want A1, I'm going to plug in 1. So 1 plus 1 over 2 times 1, which will be 2 over 2, which is 1. A2 is going to be 2 plus 1 over 2 times 2, which will be 3/4. A3 will be 3 plus 1 over 2 times 3, which will be 4 over 6, or 2/3. A4 will be 4 plus 1 over 2 times 4, which will be 5 over 8. And then our last one, A5, will be 5 plus 1 over 2 times 5, which is 6/10, or 3/5. Okay, so this sequence is going to be 1, 3/4, 2/3, 5/8, and 3/5. Okay, and this next one's kind of a combination. Okay, so we're starting with 2, and then I have this formula, which involves both an n and an an. So A1 is 2. A2 is really going to be A1 plus 1. So that subscript means n is actually 1. So we're going to have 1 times A1, which is 1 times 2, which is 2. A3 is going to be A2 plus 1. So our n is 2. So 2 times A2, which is 2 times 2, which is 4. A4 is going to be A3 plus 1. So 3 times A3. 3 times 4 is 12. And our last one, A5, will be A4 plus 1. So 4 times A4, which will be 48. So this sequence is 2, 2, 4, 12, 48. Okay, now we're going to go the other direction. Given the sequence, can we write the sequence recursively and explicitly? Okay, for recursive, we always have to start with A1. So A1 in this case is 2. And then to get to the next term, AN plus 1, in this case we're adding 2. So this is going to be AN plus 2. Explicitly, we have a couple options. First option is to use our formulas for arithmetic and geometric sequences. So in this case, this is arithmetic. Or I can just look at the relationship between the term number and these values. So if I do that, I'm looking at, well, these are just double. So this would be 2n. But alternatively, I could do A1, which is 2, plus n minus 1 times our d, and that would also work. For this next one, recursively, A1 is 1, and to get to the next term, I'm multiplying by 3. So 3an. Explicitly, this is a geometric sequence with my A1 being 1. So this would be 1 times my common ratio is 3 to the n minus 1, which would just be 3 to the n minus 1. All right, so we have the sequence 1, 5/3, 7/3, and 3. Well, if you think about these two, this would be 3/3, this would be 9/3. So this sequence is arithmetic because we're adding the same thing every time. We're adding 2/3. So we say there is a common difference. Okay, that difference being 2/3. So when writing the nth term formula, the general formula for arithmetic is AN equals A1 plus n minus 1 times d. So what we're going to do is fill in the specifics for this sequence. So AN is going to be A1, which is 1, plus n minus 1 times our common difference of 2/3. And you can leave it just like that. Now we can use that to find the 12th term. So A12 would equal 1 plus 12 minus 1 times 2/3. So this will be 11 times 2. So this is going to be 3/3 plus 22/3 would be 25/3. Okay, the next one we want the sum. The general formula for a sum of an arithmetic is n over 2, 2a1 plus n minus 1 times d, and then we fill in the specifics. So the sum formula for this is going to be n over 2. 2 times a1 is just going to be 2, plus n minus 1 times my common difference of 2/3 again. Okay, then we can use this to find the sum of the first 20 terms. So S20 is going to be 20 over 2, 2 times 2, plus 20 minus 1 times 2/3. And you'll have a calculator to do this. So it's going to be 10 times 2 plus 38/3, which when we simplify this is going to be 440 over 3. Okay, the next one here is going to be geometric. If you divide any term by the previous term, we're going to get a common ratio of 2/5. So this is geometric because there is a common ratio. Okay, so we'll write the nth term here. The general formula for a geometric is a1r to the n minus 1. So for this series, my a1 is 50. My common ratio is 2/5 to the n minus 1. Then we can plug in 8. So our 8th term is going to be 50 times 2/5 to the 8 minus 1, which when you plug this in the calculator is going to be 08192. For the sum, the general formula for a sum of a geometric is a1 minus a1r to the n over 1 minus r. So for this specific series, a1 is going to be 50 minus 50 2/5 to the n over 1 minus 2/5. And you can leave it just like that. So for the sum of the first 15 terms, that's going to be 50 minus 50 2/5 to the 15 over 3/5, which is going to be 83.333 repeating. So I've got two sequences here, 3 something h, 3 something h, and we're going to find an h so that it's arithmetic and at geometric. So we're going to use our nth term formulas. For arithmetic, an equals a1 plus n minus 1 times d. And then plug in this information of find the common difference. So 36 is going to equal a1 is 3, so this is a1, a2, a3, plus n is 3. So 33 equals 2d. So my d is going to be half of 33, will be 16.5. So my h is going to be 3 plus 16.5, which is 19.5. Now, we'll do the same thing with geometric. So an equals a1r to the n minus 1. So 36 is going to equal 3r to the 3 minus 1. So 36 divided by 3 is 12, is r squared. So r is the square root of 12, which would be 2 root 3. So my h is going to be 3 times 2 root 3, or 6 root 3. Okay, so we're going to write a sequence that has 3 arithmetic means between 2 and 5. So we're going to have 2 followed by 3 numbers and a 5. So in this sequence, this is a1, a2, a3, a4, and a5. So I'm going to use the nth term formula. To find what the common difference would be to generate this sequence. So 5 is going to equal 2 plus, since that's a5, 5 minus 1 times d. So 3 equals 4d. So my difference is 3/4. So we're going to add 3/4 to form this series. So 2 would be 8/4. Plus 3/4 is going to be 11/4. 14/4, 17/4, and 5. Next up, we have a geometric sequence, and we're going to insert 3 geometric means between 2 and 1/8. So we're going to have 2, something, 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 1/8. So again, I'll number these: A1, A2, A3, A4, A5. We'll use the nth term formula for geometric. So an equals a1r to the n minus 1. So here we've got 1/8 is equal to 2 times some common ratio to the 5 minus 1. So I'll divide by 2, which is 1/16 is equal to r to the 4th, which means r, since 16 is 2 to the 4th, if I take the 4th root of this, my common ratio is going to be 1/2. So my sequence is going to be 2, 1, 1/2, 1/4, and 1/8. Okay, next we're going to find the first term in a geometric sequence with A4 being 4 and A4 being 16 and A7 being 2. So we've got 1, 2, 3, 16, 17, sorry, let's number these. A1, A2, A3, A4, that makes this A5, A6, and A7. Okay, well, what I'm going to do for this problem is redo the numbering to find the common ratio. So we're going to pretend for a minute that that's A1, that's A2, that's A3, that's A4, and find the common ratio this way. So 2 is going to equal 16r to the 4 minus 1. So 1/8, when I divide 2 by 16, is r cubed. Cubed root of 1/8 is going to be 1/2. Okay, then we're going to go back to our original numbering and come up with the first term there. So 16 is going to equal A1. The common ratio is 1/2. If 16 is our term, that means r is 4, so 4 minus 1. So 16 is going to equal A1/2 cubed, which is going to be 1/8. So I'm going to multiply both sides of this equation by 8, which means A1 is going to be 128. Okay, now we have the binomial theorem. So we're going to use the binomial theorem to expand this first one, x minus y to the 4th. So the first thing we need to do is look at our Pascal's triangle, specifically the 4th row, which is 1, 4, 6, 4, 1. So those are going to be our coefficients. So I'm going to put a 1, leave a space, plus 4, leave a space, plus 6, leave a space, plus 4, plus 1. Then I'm going to take the first thing in descending order. So x to the 4th, x cubed, x squared, x, no x. And then the second thing, which ended a negative y, there's no negative y here. This is going to be negative y squared, negative y cubed, negative y to the 4th. Okay, and then we'll simplify. So this is going to be just 1 times x to the 4th is x to the 4th. This next one's going to be a negative 4x cubed y. When we take the negative and square it, it's positive. So this will be plus 6x squared y squared. Next one's going to be negative 4x y cubed, followed by a positive y to the 4th. So anytime there's a negative, the terms will alternate like that. Okay, so for our next one, we need the sixth row of Pascal's triangles. So 1, 6, 15, 20, 15, 6, and 1. Okay, so we're going to need some room for this one. So I'm going to put the 1, leave a space, plus 6, plus 15, plus 20, plus 15, plus 6, plus 1. Okay, then we're going to take the first thing in descending order, so x squared. So we're going to have a x squared to the 6th, x squared to the 5th, x squared to the 4th, x squared cubed, x squared squared, x squared, and no x squared for the last one. Then we're going to take the negative 2y in ascending order. Okay, so there's no negative 2y here. There'll be a negative 2y squared, negative 2y cubed, negative 2y to the 4th, negative 2y to the 5th, negative 2y, to the 6th. This takes a lot of room. All right. Now, I'm going to start simplifying. So I'm going to do the power, and then I'm going to do the negative 2 to the power. So this will be, we multiply those, so it's going to be x to the 12th plus, we'll have 6x to the 10th times negative 2y plus 15x to the 8th times negative 2 squared is 4y squared. Our next term here, we're going to have that 20x to the 6th times a negative 8y cubed plus 15x to the 4th times 16y to the 4th plus 6x squared negative 32y to the 5th for that. And then lastly, a positive 64y to the 6th. The last step then is going to be to multiply the constants together. So we'll have x to the 12th minus negative 2 times 6 is 12. Okay, our next one, we've got 4 times 15, which is going to be 60. Negative 8 times 20 is a negative 160. X to the 6th y cubed. 15 times 16 is 240. Six times a negative 32 is negative 192. And 64y to the 6th. Okay. Last thing we're going to do here is the specific term of a binomial expansion. The formula is nr x to the n minus r, y to the r, where r is one less than the term we want. Okay, so for this first one, the power, the n is going to be the power, so that's going to be 12. So this is going to be 12. If this is 5, my r is 4. We're going to have x to the 12 minus 4, which is 8, and then the negative 2y to the 4th. Use your calculator to do the combination, or you could use Pascal's triangle. This will be 495, x to the 8th. This will be a positive 16y to the 4th And then we multiply those together. To get that. For the next one, it's going to be 12 and 9. X to the 12 minus 9 is 3. Negative 2y to the 9. Using the calculator, that's going to be 220. X cubed. This will be a negative 2 to the 9th is 512. So if I multiply those two constants together, we get a negative 112,640 x cubed y to the 9th. So that is your Unit 8 review.